So here we go. We have some vocabulary we've got to make sure we get because I don't think you've ever done these before. So what's a matrix? A matrix is a rectangular array of numbers arranged in rows and columns. All right, so I'm going to put an example here. There's a matrix. It's a rectangular array of numbers arranged in those columns. You see a rectangle shape there, and rows of numbers and columns of numbers. Rows, like if I go to the gym and I say sit in the second row, aren't these the rows? Rows go this way. But if I look at the White House and I see columns, columns go this way. When we talk about the dimensions or the order of a matrix, the dimensions are simply the size of the matrix, and we indicate that by stating its rows by its columns. Okay? This is not a time sign, it's by. If I said, what are the dimensions of this room? You might say 30 by 40, right? And that's how we identify matrices, rows by columns. So what are the dimensions of this guy? 2 by 4. This is a 2 by 4 matrix. He has 2 rows and 4 columns. Now what do you think? Okay, that should be either an X on the end of C, it should say square matrix or square matrices. So fix my error, please. A square matrix or square matrices are what? Take a wild guess. What do you think it means to be square? Sir?
It's like even on like the same number.
Same number of rows as columns. Same number of rows as columns. I'm not going to write all these down. You can write down what you need. A square matrix has the same number of rows as columns. So it would be like a 2 by 2, 3 by 3, 4 by 4. If we had a ton more time, we could spend basically a whole semester talking about matrices, the study of linear algebra. But we don't have time. Square matrices are, you can do lots of things with squares that you can't do with other matrices. They're special. Square matrices are special. Entries or elements are the numbers inside the matrix. So for example, this is an entry or an element of matrix A. So a matrix is a rectangular array of numbers. Those numbers are called entries or elements. Now, if I wanted to talk to someone who wasn't right here with me, like all the people that watch this video, the entry right there would be classified like this. That is how I would talk about that particular entry. The little a refers me back to matrix A. The little a says, okay, you're inside matrix A. And the 1, 3 says you are in the first row, third column. So if I look at matrix A, row 1, column 3, isn't that number a 6? So what would this be? What entry is in that spot? Izzy? 5. That is the entry that is in the second row, second column. So, remember with our triangles, we used capital letters for the angles, the vertices, and lowercase for the sides. It's got the same kind of thing going on. Capital letters for the matrix, small corresponding letters, so everything in here is going to be an A, but it's going to be a little a. All right, a scalar is simply the matrix and vector. Those of you in physics have heard about scalars. A scalar is simply a real number. So it's a real number. That's it. That's what a scalar is. A scalar is a real number. We're going to do some stuff with it in a minute. What do you think equal matrices are? What do you think? Equal matrices.
That they are equal to one another inside the matrix.
Well, I think you know what you're talking about. Let's see if we can clarify that a little bit. Equal matrices have to meet two requirements. First of all, they have to have the same dimensions. Does that make sense to you? That if they're going to be equal, they have to be the same size. And they have to have the same corresponding entries. In other words, this is what it takes to be equal, those two things. You're going to need an equal matrix. In other words, it's not enough to say they have the same entries. Because these two matrices have the same entries and they're the same size, but they aren't equal. Do you see? You need this right here. That means this number has to be the same as this number. And this one, and this one, and this one, and this one. So these are not equal. That word corresponding is really important. Same dimensions, same corresponding entries. Now the transpose, yes, Alexis?
So they are basically copies of one another.
Yes, except matrices are used solving systems of equations, and so one of them might have numbers in it, but the other one has letters in it. But whatever number is here will be the value of that letter. So if that's an A, it'll say A equals 1, B equals 2, you know, whatever. But yes, they are copies of each other, basically. All right, I'm going to put a square matrix up here, and I'm going to show you what the transpose is, and then we'll talk about the definition. So if matrix A, I use a different letter, I'll say B. If matrix B is 1, 2, 3, 4, then B transpose, and that's the notation for the transpose. B transpose would be 1, 2, 3, 4. Tell me what I did. What happened when I transposed this matrix? Alexis?
2 and 3 switched.
Well, when it's a 2 by 2, it's kind of hard, yeah, to come up with the right definition. But what I did was I interchanged the rows and the columns. When you build the transpose, you interchange the rows and the columns. So if it was a row of the original, it becomes a column of the transpose. If it was a column of the original, it becomes a row of the transpose. So what is a transpose? It's the new matrix formed by interchanging rows and columns. So whatever is row 1 of the original becomes column 1 of the transpose. And believe it or not, the transpose has uses. And then the trace. The trace of a matrix, and it would be identified like this, as a TR out in front of it. By the way, I always use a capital letter when I do my transpose, but that can be a lowercase t also. Any T that's written up above like that, it means transpose. The trace for this matrix, I'm doing matrix B, the trace is 5. The trace is the sum of the entries on what's called the main diagonal. And the matrix must be square. You cannot do a trace. You can do a transpose anytime, but you cannot do a trace unless the matrix is square. And it is the sum of the entries on the main diagonal. This is the main diagonal. From the first number to the last number. Add them up, however many there are. This one only has 2, If the matrix were bigger, there could be more numbers in there and you simply add them up. Believe it or not, that number's important too in some matrix operations.
So is this, so in order to do the trace, like it has to be a square matrix?
Yep, that's what I wrote right here.
Okay.
Yep, must be square. All right, now we're gonna do some work. We're gonna actually do some work. So, got a bunch of matrices across the top there, and we're gonna add A and B. Anybody have a wild guess? If you guess, you'll be right, I guarantee you, what the sum of A and B will be. Alexis?
Never mind.
Oh, come on now, take a wild guess. I heard somebody say it, what'd you say? 7 right here, why is that a 7? Because you're adding the 1 and the 6? Alright, now what's gonna go here? 1, negative 2 plus 3, what's gonna go here? 3, and finally, 1 again. That's the sum. Now tell me how we did that. How are you gonna describe this? How do we add matrices? Izzy?
You take each like entry that's like corresponding with each other and you add them together.
Yeah, that's right. You add corresponding entries. That's exactly right. You add corresponding entries. Now, because that's how we do it, what about the matrices themselves? Can I just pick 2 random matrices and add them together? What has to be true about them? Ethan?
They have to be like the same, like they both have to be like square matrices.
Well, they don't necessarily have to be square, but they have to have the same dimensions.
Yeah.
So if one of them's 2 by 3, the other one has to be 2 by 3, because don't they have to have the same, both have to have corresponding entries? So they gotta be the same size. They do not have to be square. These happen to be square, but as long as they have the same dimensions, you can add them. Okay, we add them by adding corresponding spots, so they have to be the same size. Now, what about A plus 2B? Now wait a second, see that 2 right there? You might say, oh, he's a coefficient. Well, he is, but we call him a scalar, because he's just a number. He's just a number. And in matrix and vector land, numbers are called scalars. What do you think 2B is? Here's A, you got A, but what would 2B be?
12,
12, 6, 0, negative 8. How do we multiply a matrix times a scalar? We like distribute, right? We just take the scalar times everything. So what would that sum be? We know how to add them now. How do we add those? What do we end up with?
13, 4,
13, 4.
3.
How's that look to everybody? Is that okay? So easy. All right, how about 2A plus D?
Can't we not do it?
Can we not do it? No, we cannot do it. You are right. Why can I not do 2A plus D?
The difference.
They are not the same size. In kids, you cannot add or subtract unless they are the same size. Matrix operations have rules to follow, and if you can't make it work, then it's no solution. So the answer to C is either empty set, can't do, not the same dimensions. However you want to write it, it's not a doable problem. Does everybody see that? I can do 2A, but I can't add it to D. All right. Here's where we really got to pay attention. This is easy, but you have to stay organized when you do matrix multiplication. The rule for matrix multiplication is this, to see if you can do it. What's the rule for addition? The
They're the same
matrices have to
size.
be the same size, that's it, period, same size. For multiplication, that's not the rule. If you're gonna multiply these two matrices, first of all, write down their dimensions so that you can look at their dimensions. What are the dimensions of this matrix?
2 by 4.
2 by 2. Right? What are the dimensions of this one?
2 by 2.
2 by 2. The rule for multiplication is these two have to match. If you're gonna multiply, the middle two dimensions, columns of first, rows of second, have to match. So in other words, if you have a 3 by 8 and an 8 by 5, you can multiply those. You can't add them, but you can multiply them. Similarly, if you had a 2 by 3 and a 2 by 3, you can add those, but you can't multiply them. See? The rule for multiplication is those inside dimensions have to match. Well, these do. So I'm going to multiply them. These dimensions right here tell me how big my answer will be. So my answer is going to be another 2 by 2. Insides match, must match, and if they do, then I can multiply, and the outsides tell me how big my answer is. 2 rows, 2 columns, another matrix that looks just like these. What would the dimensions of this one be? If I had a 3 by 8 and an 8 by 5,
3 by 5.
my answer would be a 3 by 5, and this one's not good. Okay? Now, everybody with me so far? Now we gotta start filling in these numbers. Okay? Now, this number right here, I'm gonna figure out what he is. He is in the first row and the first column. So I am going to use the numbers in the first row and the first column to figure that out. That position is row 1, column 1. So I'm going to use row 1 and column 1. I always do rows first and then columns. Always, everything is row and then column. So I'm going to write down the numbers in the top row. So 1, -2. Right next to them, I'm going to write down the numbers in the first column. I'm going to multiply each pair and add them together, and that's going to give me that number.
7.
Oh,
Like, you just
Zero.
6.
I think it's just 6, isn't it?
6.
So that's 6. So I have to take both numbers in the first row and multiply them by the numbers in the second row. So I wrote down 1, -2, and then 6, 0. Multiply each pair and add them up. All right, so now we're gonna come over and do this one. Same thing, only what position is this? Row 1, column 2. So now I'm gonna use this column, so I'm still gonna write down my 1 and -2. But now next to there, I'm gonna put 3 and -4. You see what I'm doing, guys? It's easy, you just have to be organized. So multiply each pair and add them up. Looks like that number's gonna be 11. Well, you know where this is going. Now I'm gonna go to row 2, column 1. So this number is, hi Grace, be safe and smart. This is an 18. Don't forget to email me. And then, lastly, row 2, column 2. So there's my 3 and my 5, and my 3 and my -4. -11. Kind of another one. A few more things to do here, and then I'll do a different activity. Alright, so here we go. We're gonna multiply D times C. I'm taking a bunch of time to write this down. I'm hoping it's gonna work. All right, what are the dimensions of D?
A 2 by 3.
D, it's not 2 by 2.
And 3 by 2.
No, it's not 3 by 2
It's 2 by
here.
3.
It's 2 by 3. Remember, it's rows by columns. 2 rows, these are rows, bleachers, rows of bleachers, that's 2, and then 3 columns. Everything we do is row first. Roman Catholic, rows, columns, RC. All right, what are the dimensions of this guy?
2 by 3.
3 by 3. Can we multiply?
Yes.
Yes. And the answer will be another 2 by 3. So in other words, the answer is going to look like this one. All right, here we go. You gotta figure out what's going to go right here. Well, that's row 1, column 1, right here. So write down the numbers in the row, 2, -1, 3. And then next to those, write the numbers in the column, 1, 0, 1. Multiply each pair and add it all up. So this number is a 5. Everybody agree with that? Okay, we'll do one more together, and then I want you to do some by yourself. Let's go over here and do this one. This is gonna be, right here, this is gonna be row 1 still. But now it's gonna be column 2. So what do we get? Row 1, column 2. 7? It's -2 and -3. That's -5 and 12 would be 7. I don't know what you typed in. You're probably better off just doing it. All right, can you fill in the rest for me? Fill them in. See what you can come up with. Let's see if we can all get the same answer. Remember, you do rows of the first, columns of the second. Please don't write my answers down, they are probably wrong. I'm gonna need you to check on them. Do not write mine down, check them and see. So let's talk about the ones where we don't match.
do a C times D, would you not be able to do that?
Yep, you can't do C times D. So in like with real numbers, multiplication is commutative, right? You can do it in either order. 2 times 3 is 3 times 2. But in matrix land, it's not commutative. And if you could do it, you would get a totally different answer. Order matters. All right, how do these numbers look? Anybody want to talk about any of those numbers? Izzy, which one?
The 5 and like.
This 5 right here?
Yeah.
All right, so that 5 would come from multiplying row 1 times column 3. So that's 4 and 1 and 0. Anybody else? It's so easy to make mistakes with this. You have to really be careful. Anybody else have a question on any of those? All right, what about F? AC.
You can't do it.
Can't do it. Why can't we do AC?
Because they're not the same.
Because it's a 2 by 2 times a
3 by 3.
3 by 3, and the inside dimensions don't match. So therefore, it is a not doable problem, and we have another empty set. We get a lot of empty sets when we're dealing with matrices, because the rules are so strict. All right, one more multiplication, and then we're gonna stop. All right, this last one we're gonna do before we move on. All right, so A transpose times B. All right, now remember what A transpose means.
Which isn't
Change the rows and columns. So I'm gonna look up here at matrix A, and in the original matrix A, the row, first row, is 1, -2. So I'm gonna copy that as the first column. And then the second row, which is 3, 5, is gonna get copied as the second column. So that's the transpose. And then B, I'm not doing anything to it. And my job is to multiply these. Can I?
Yes.
Yes, they are multipliable. And since they're 2 by 2s, inside dimensions match, I'm gonna get another 2 by 2. All right, let's see if you can fill those in. You did a great job with the last one. Let's see if you can fill those in. When you do multiplication, there is no special pattern. You just end up with random numbers. So you can't really predict, you just have to work them all out. I could easily make a mistake. Which one?
I thought it was -9 and -4, but I
Oh,
don't know.
it could be. It absolutely could be. So that is row 1, row 1, column 2, right? Would be that spot right there.
Yeah, but I think you're right.
I write down 1, 3, and then I write down 3, -4, and I multiply each pair and add them up. rest of them look okay? Got it? Okay. Check something real quick. Alright, so, last thing we're gonna do before we do our special activity is we're gonna do this problem on our calculator. Okay, we're gonna do this problem on our calculator, because I can. Alright, so let's get them out. So stay with me, please pay attention so I don't get cranky because I have to repeat everything. Alright, first thing you need to do is right here in the first column, right there, do you see how it says matrix above that little button?
Yes.
Okay, so we're gonna press second matrix, and that's gonna bring up our matrix menu. Now, I put matrices in my calculator before, and once you put them in, they're there. So they're in there, I'm not worried about that. I'm gonna type right over any numbers I need to type over. So whatever you've got in there, don't worry about it, doesn't matter. If you have nothing, that's great. I am going to put in matrix A. First of all, I'm gonna put in matrix A, so I need my paper. I'm gonna put in matrix A. I'm not putting in the transpose, we're gonna let the calculator do that part. I'm gonna literally enter the matrix A that's on my paper. So I click over to edit, because that's how I put information in, right? And I press enter. Now, how big is matrix A? I'm putting in the matrix that's on my homework paper, or on my notes paper. How big is it?
2 by 2.
2 by 2. So you say 2, enter, 2, enter. Because you gotta tell the calculator how many slots you need to fill in. So 2, enter, 2, enter. Okay, set it up for you. Now let's put the entries in. So if you type 1, enter, your cursor goes over to where the -2 is. So -2, enter. Now it's down where the 3 is. And finally it's where the 5 is. You got all 4 of those numbers in? As soon as you put that 5 in and press enter to get it in place, press second quit. Right in the top row, second quit. We gotta get out of matrix land, okay? Now we're gonna go back in because we have to put in matrix B now. If we're gonna do this multiplication, we have to put in matrix B. So second matrix, over to edit, but now go down to B. You see now how you can highlight B? Press enter. How big is matrix B? 2 by 2. Put in his numbers, 6, 3, 0, -4. And then second quit. So now in your calculator, you have a matrix A and a matrix B. Okay, here we go, second matrix. Now, right now, as soon as you hit second matrix, A is highlighted, right? So press enter. And now matrix A is on your screen. But we don't want matrix A, we want the transpose of it. So second matrix. Click over to math. Edit is where you put the numbers in. Names is where you call it up to the screen. Math is where you do things. So notice that the second item in the list is the little superscript T. Press it. So now on your screen, you should see this. Do you see this on your screen? So now hit times, because you want to multiply it. And then second matrix, down to B, and enter, and then enter. And it will produce that answer. All right, so we got to do something else real quick. So we'll do some more stuff, we'll do a lot of stuff with the calculator. But let's refresh what we just learned. To put your matrix in, you go over to edit, use that matrix edit menu. To call it back up, to get it onto your screen and do stuff with it, you do names. If you want to do some matrix operation, then you use in the matrix menu math. And then there's a whole list of stuff, some of which we'll use and some we won't. Got it? Okay, so that takes care of that. All right. Now,